All right, hello. I'm Dr. Garris. I'm chair of the physics program here at UH Clear Lake, and I want to thank everybody for attending tonight. I also want to thank some of our sponsors and some of the people that helped to organize our event, Drs. William Houston, Dr. Penn, and Dr. Massoud, as well as the School of Business, our School of Science and Computer Engineering, Office of Sponsored Programs, and our provost. We've done 4 of these other Distinguished Physics Lecture Series talks. This is the 5th in the series. And every time we've talked a little bit about some of the new programs and expanding programs that we're doing. And so we talked about the Physics MS a few years ago, the Collaborative PhD program, the Technical Management Subplan. And one thing I wanted to mention tonight was about our new Physics BS program, which has just gone online. And also, there are several scholarships available for any students who want to pursue this Physics BS. So it's a new thing. Also, I want to mention that for those who are interested in the topic tonight, that there is going to be an effects of nuclear weapons class that we're offering in the spring. So if anybody's interested in signing up, that's going to be offered here on this campus. And we have a partnership on this talk with our political science program. And so there's information about both the physics and the physical science and the political science programs outside. And you'll get a chance to hear a little bit more about that. We saw a little bit on the way in, and you'll get to see a little bit more about that at the reception afterwards. So my main job tonight is to introduce the speaker, and then after the talk, you'll have a chance to ask a few questions. Now, President Alan Sessoms, he's the president of the University of District of Columbia system, and he's been in that office since 2009. Before that, he was the 9th president of Delaware State University, where he helped build the infrastructure to grow to 10,000 students and added some of the first doctoral programs at that university. Before that, he was at Harvard University, and he was a fellow within the Institute's John F. Kennedy School of Government. Before that, he was president of Queens College in New York City. And before that, he was the executive vice president at the University of Massachusetts. So for about 14 years before all this, in his time in academia, he was in the U.S. State Department, and he was in the Bureau of Oceans and International Environment and Scientific Affairs in Washington, D.C. He was the counselor for Science and Technological Affairs at the U.S. Embassy in Paris, France, and he was a deputy ambassador at the embassy in Mexico. So he's been all around the world. He's had several postdoctoral positions at Brookhaven, at CERN in Switzerland. He's been a faculty member at Harvard University. He had an undergraduate degree from Union College in physics, and he got a PhD from Yale University. He's a fellow in the American Physical Society, and although he speaks French, Spanish, and German, please, any questions, ask him in English. We're done. So with that, I'll turn it over to our speaker tonight, President Alan Sessoms.
Good evening. I'm lonely. You can move down if you want. I know it's a long weekend, which is a good thing, but it is Houston. I'm going to talk a little bit about the politics and the technology related to the reduction of nuclear weapons. How many of you here have seen a nuclear weapon go off? Good. So, well, it is a good thing. Can you hear me if I walk away from this? We're using technology here that's proven. So when I push a button, nothing happens. That's the proven part. So what's on? It says on off. We'll try that. Okay, that's back in the old days, people were testing nuclear weapons in the atmosphere. The United States did a lot, and we did a lot over the Pacific. And just wanted to give you a sense of what a nuclear explosion looks like in the atmosphere. That's a picture of one of the thermonuclear shots, that they call them shots then, as opposed to tequila now, we did over the ocean in the Pacific. There's another one. These are pretty fearsome things. To give you a sense of the size, those little dots are battleships. They're about a couple of 3 football fields in length, and they're kind of dwarfed by what is a fairly large thermonuclear explosion at the Bikini Atoll in the Pacific. I like this just because it's pretty. Oops. These are pretty fearsome devices. And the idea was to figure out, and everybody thinks this is a great idea, how to reduce the number of nuclear weapons in the world. The United States and what was Soviet Union, now Russia, had the monopoly on nuclear weapons for a long time. The British have nuclear weapons, the French have nuclear weapons, the Chinese have nuclear weapons, the Pakistanis now have nuclear weapons, the Indians have nuclear weapons, the North Koreans have something, and there are a few others nibbling at the edges, and I'll talk about those as we go along. I just want to point out that nuclear weapons are in fact useful in a variety of circumstances. And this is the problem with these things. You have, in this picture, former President Bill Clinton and the former head of North Korea walking around with a couple of nuclear weapons under his feet. And Bill Clinton famously called North Korea a pygmy. And then this is something that Tony Auth pointed out in 2003. This is what Bill Clinton said. Actually, I should have called you a former pygmy. Nuclear weapons tend to make a country look a bit outsized. So they're useful in some political contexts. And North Korea is still playing games with them now. But more than that, as someone pointed out last night in the conversation, they can be a useful deterrent. Here's another image of our North Korean friend, not particularly flatteringly illustrated. And here's a sort of renegade state that we're taking care of. This probably was Iraq back in the old days, with F-16s buzzing around the head. And the North Koreans saying, well, you know, it's the only thing that keeps them away. It serves as a useful tool in some circumstances, and that's a problem. The Israelis example is a great example, since there tends to be a little more stability in the Middle East, since people tend to believe that the Israelis have nuclear weapons. I won't have any further comment on that one unless asked. So I'm going to talk about a couple of reports that I had a hand in participating in. One was trying to prepare the groundwork for the new administration that was coming in. President Obama clearly stated in his run-up to the election that he was determined to rid the world of nuclear weapons, and that was a big deal. Well, folks started thinking about what that meant, and it wasn't completely obvious what it meant. So the Center for Strategic and International Studies, the American Physical Society, which I'm a member, and the AAAS, of which I'm a member, decided to get together and do a study of what utility nuclear weapons could possibly have in the 21st century. And once you decided what utility they had, then you could figure out what to do with them, or whether you could do anything with them at all. In the previous administration, in the administration of George W. Bush, no one quite knew what to do with these things. So the dialogue on nuclear weapons in the policy community was fairly confused. Some people thought they were incredibly important, and some people thought they were useless. So we decided, as a bunch of smart people, to get together and try to figure out which it was, or whether there was this continuum that we should be participating in. I helped organize this and didn't participate because I had a job to do, and all the folks who did it were retired. I mean, they were really smart. So, certain conclusions, and I'll just read them to you briefly. Each of these is worth a seminar. The first conclusion was, as long as other nations have nuclear weapons, the United States has to sustain a credible nuclear deterrent capable of deterring state-based nuclear attacks on the United States. That's the old U.S.-Soviet doctrine of mutual assured destruction. If you came at us, we'll take you out, so you don't want to come at us, basically. Providing an extended nuclear deterrent is part of the U.S. security assurances. One of the major reasons, for example, why Japan hasn't developed nuclear weapons, and I think I will remind you they could develop nuclear weapons in weeks if they decided to, literally weeks, is because the U.S. gives them a guarantee that if they're attacked, the U.S. will view it as an attack on the United States. A significant component of that is a nuclear deterrent that we provide. One of the things that's also been less effective is deterring global conventional nuclear war between major powers. Now, we used to do proxies all the time, and we're still messing around with proxies, but there's no war between major powers now, no conventional war, at least that we're completely convinced of. So that's something that's important for nuclear weapons in the future. And this one is a little sketchy, but contributing to U.S. status as a global superpower in the nuclear world, because that's where you play the game. If you're going to be in it, you have to be in it, and you have to be one of the big boys. That's sort of what we concluded. The trouble is it's hard to do that if you're determined to build down the number of nuclear weapons you have. Because if you have a lot of nuclear weapons and they only work most of the time, that's good enough. If you only have a few nuclear weapons and they only work most of the time, you have a problem, because if you use it once and it doesn't go off, it becomes an issue. People say, well, what about the rest of them? So we've got, as you do here in NASA and other federal agencies, a workforce that's aging, the experience and expertise is declining, and like who wants, as a young physicist or chemist, to go into the nuclear weapons business? It really is not exactly a kind of a growth industry, sort of. But it's very interesting that, in fact, if you take a look at what's needed to keep a nuclear weapons arsenal safe and reliable as it gets smaller, it requires more people. It requires more money, because you got to be much more secure in the fact that these things will work. So if we're going to be building down weapons, we've got to make sure that what we have left is safe, secure, and reliable. And nobody has quite figured out what that means. But we're pretending we do. The biggest threat we have, and I'll just mention this, is nuclear terrorism. The biggest concern is that some rogue group gets a nuclear weapon and delivers it, and it goes off on U.S. soil. Biggest threat. The second biggest threat is non-proliferation, the proliferation of nuclear weapons to more countries, including North Korea and Iran. And these are very serious issues right now, and we haven't found a solution to either one of those. Who knows what the best delivery system is for a nuclear weapon? Okay, I'll tell you. It's a 747 or a 737 that just lands at an airport. Wonderful delivery systems. These things aren't radioactive. People in submarines, the guys in our Navy and the women in our Navy sort of sleep next to these things. So you can put it in the cargo hold of an airplane, put a little shielding around it, nobody will notice. It's a great delivery system. It's a big concern. Another concern is we have to take care of what is left of the nuclear weapons we're not going to be using anymore. I mean, there were tens of thousands of these things. They're laying around. Okay, you're not going to use them anymore. What are you going to do with them? You've got to secure them and then get rid of the stuff inside that makes them into weapons. And that is an interesting exercise, especially when you're, say, in the former Soviet Union, and there's a bunch of these laying around, and somebody hasn't gotten paid for 3 years, and they just want to sell one. Or the Pakistanis, who have some problems with stability right now and a bunch of nuclear weapons sitting around. Okay, so the game is to figure out how to keep them from falling into the wrong hands. And then we also want to make sure we worry about the Russians, who seem to have an interest in using nuclear weapons as a deterrent, especially in Europe. In fact, when we were talking about building a missile shield, which we said was against the Iranians in particular and the North Koreans, in Central Europe, the Russians started beefing up their tactical nuclear weapons and threatened, for example, Ukraine with a nuclear response if they really embraced the U.S. nuclear shield. So that was a little worrisome. a lot of work has gone into decreasing the number of nuclear weapons. This is just the U.S. inventory. It doesn't count the Russian and Soviet inventories before. So this is where we started. I mean, back in the old days. I remind you, this technology is 65 years old, which is, in most cases, totally obsolete. I mean, the only thing that's been around that long that we still use, well, there are two of them, the automobile and the airplane, but they don't look exactly the same. This is old stuff. In some sense, anybody can make one of these things. Anybody, not you, not me, but a country certainly could dedicate the resources to doing this. The first nuclear weapons were designed without the computers. Most of the calculations were done by women, not men, because men are sloppy, and women really pay attention to the numbers, using adding machines, and a few smart guys, and some pretty good engineers. And we knew that the uranium weapon would go off the first time, so we never tested it. There was an absolute certainty. You put it together, it was going to go boom. It did. So these things are not very hard to do. So we build them up. That was where we were during the Cuban Missile Crisis, which, much to somebody's surprise, or everybody's surprise when we studied at the Kennedy School, was really a lot closer to nuclear war than people thought. That was pretty hairy. The maximum number of warheads in the U.S. inventory was over 31,000 in the 60s. I mean, it's a gigantic number of these things. Went down a little bit. The Warsaw Pact has been dribbling away. We had these agreements with the Soviet Union to start dismantling nuclear weapons. Started going down. When the Soviet Union disbanded, it dropped like a rock. And it's been going down ever since. There's been a lot of effort to just pare down the number of these things because you don't need them. People can't figure out what the heck to do with them. So there's been a lot of effort in building down the nuclear weapons stockpile in the United States. And to some significant extent, also Russia and its former Soviet colleagues. The Chinese, the French, and the Brits have not done exactly a lot, and some have built up, like, well, yeah, a few. One of the things that we were worried about in the technical community was, like, what happens if you really build nuclear weapons down to zero or a small number? President Obama, when he came in, said he wanted to do this. And he made, which I'll mention, a famous speech in Prague saying, I want to have a world without nuclear weapons. Well, some of us are kind of skeptical about that for the reasons I mentioned before. If anybody's got nuclear weapons, it's probably a good idea for us to have some too. So zero was a small number, but if you went down to a small number, how small could you go and still have them useful as a deterrent and other things? So the American Physical Society, working with the American Association for Advancement of Science, again, did a study. This was published this year. Technical steps to support nuclear arsenal downsizing. And some of the conclusions were really surprising to us. The key points was, if you're doing this in partnership with somebody, you have to verify that they're doing what they say they're doing. And they have to verify that we're doing what we say we're doing. But a lot of this stuff is classified. You don't want to let the adversary know how advanced you are in some of these technologies. And you don't want the bad guys who might be a part of some international inspection regime to know more than you want them to know, which is basically not very much. So you had to figure out how to verify this process of building down the nuclear weapons and dismantling the stockpiles. That was going to cost a lot more money than we've spent in the past, because we don't train people to do this stuff anymore. You also want to sustain the capability and expertise to ensure that what you have left over is safe. And that's harder than people think. We haven't tested in a couple of decades. And nuclear weapons are sort of an art, not a science, because still in the end, as we were testing on the ground at the Nevada test site, some of the things went fud. I mean, it didn't work. And we've been doing this stuff for a long time, and every now and then it didn't work. And people are still scrambling in some cases to find out why they didn't work. So you got to really sort of look at this stuff in a fundamental way to understand how these pieces of aging machinery are still going to be made reliable, and you got to replace parts of them. And one of the problems with nuclear weapons is that They were designed artfully, and every one sort of looked different. So what happened was, when these guys got a design after blowing things up in the ground that worked, they didn't change anything. Absolutely nothing. Even if there were stupid things there, struts that didn't matter, shapes that didn't really make a difference, they weren't going to change anything because, by goodness, this thing worked, and I'm not going to mess around with this anymore. So you actually can't model these things particularly well, because nobody knows the physics and engineering well enough to know what matters. So testing and not testing is a big deal. When you don't test, the nuclear weapons become, in principle, less reliable. But when you build down to a smaller number of nuclear weapons, you need the reliability to go up, and that makes it a really interesting exercise. The last piece, and this is the nuclear proliferation piece, is that we will ensure the peaceful use of fissile material. As nuclear power becomes more interesting to countries all over the world, especially when people are worried about global warming, more nuclear power plants are going to be built. What are you going to do with the stuff that's burned in the nuclear power plant, the fissile material? Much of that material is not particularly useful, but some of it can be used directly in nuclear weapons. But more than that, like the Iranians are doing, they said, well, we want to have a peaceful nuclear program, so we're going to enrich uranium, which is just an element found everywhere. They're going to enrich uranium so it can be useful in the nuclear power plants. And if you enrich uranium up to a certain point, it's very useful with nuclear power. And if you take it a bit further, it's really good for nuclear weapons. Well, the Iranians are arguing that, we are very peaceful, fun-loving people, and we don't want to blow anybody up. We just want to make these power plants work. Well, my view is, and we know that's not true, but my view is that if you're going to do something nice just for nuclear power plants, you should collaborate with all your friends around the world, like the Russians who built your nuclear power plant. They only have one. And not build 10 different facilities underground in hidden places and not tell anybody about them, and still swear in a stack of Bibles that you're only doing it for peaceful purposes. They got a nuclear weapons program, and the question is how you, as an international community, and the U.S. in particular, ensure the peaceful use of those materials once the cat is out of the bag. Because as I say, making nuclear weapons is not that hard if you have the stuff to make it. The hardest part is getting the stuff. So we recommended, and we briefed this to the Obama administration as they were coming in, before the report was published, that the U.S. should declassify the total number of nuclear weapons deployed, reserved, and retired in its arsenal, just as a confidence-building measure. So everybody in the world said, you got to tell us how many nuclear weapons you have so we know when you go down that you're actually going down. The U.S. had never, ever declassified that number, never talked about it. Neither had the Russians or the Chinese. We can guess on the Chinese. And the British and French have small numbers, but they never said what they were. We recommended that we establish international centers for verification research, because you can't just check each other. I mean, there's reasons why folks don't believe what the United States says. There's been a lot of talk, in particular by certain senators from various parts of the country, including Texas, that we should not verify the new treaty with the Russians, the START treaty with the Russians, because we can't trust the Russians not to cheat. Well, I just want to inform you that the country that's cheated most on treaty obligations is the United States. For example, in the Comprehensive Test Ban Treaty, we haven't even ratified it yet. And there are other things that we sort of snuck around the corner on that I can't talk about, but we are not all that reliable. And if I were somebody else, I wouldn't trust us either. So what you really want is to have all this stuff verified internationally and objectively. So you need to set up research centers for folks who can work with you to do these kind of things so they can assess that what you say you're doing is what in fact you're doing. It's this trust but verify stuff that Ronald Reagan pushed out. And then, push the wrong button. And then, go back. The last piece is to do what we call nuclear archaeology. If you go into a facility and somebody said, I use this facility, I produce a certain number of tons of uranium for nuclear power plants or for nuclear weapons, how do you know they're telling the truth? How do you know they're not saying they produce 5 tons when they produce 20 tons and they put another 15 aside? So if the case they decided, well, we don't trust you anymore, we build more weapons, they got it in a warehouse somewhere. So we have to sort of understand how to check out whether what they said was true. And that's what we call sort of nuclear archaeology. There's another interesting thing about this. Suppose somebody or some group set off a nuclear weapon anywhere, but say it was in Chicago. How do we know who did it? It's hard to know who did it. How do you know? There's a whole industry building up now called nuclear forensics. The APS wrote another report on this. The way to deter people or groups or nations from setting off a weapon of mass destruction in your place is if they do it, you will know who did it and you'll get them back. But if you don't know who did it, they can get away with it, it's more likely to happen, and then you don't have much of a deterrence. So nuclear forensics and nuclear archaeology are two fields that are going to have to be populated by somebody, and they're not all that jazzy or sexy, but they're incredibly important to U.S. national security. In April of this year, there was a nuclear posture review. This is something that's done every 5 years by the Department of Defense, Department of State, Department of Energy, to talk about what our posture should be with respect to nuclear weapons. And they had this great little press conference. There's Bill Gates and there's Hillary Clinton, there's Steve Chu, really the happy guy, Secretary of Energy. He never looks any happier than that, actually. It's kind of surprising. And this is the chairman of the Joint Chiefs of Staff. And they reported about the conclusions that the administration came to with respect to the use of nuclear weapons. And that was sort of a breakthrough for the United States, because we declared that we wouldn't use nuclear weapons against countries that didn't have nuclear weapons, except in some cases where we thought they might have them hidden under the pillow, pointing directly at Iran. The Iranians weren't too happy about that, and Ahmadinejad made all these noises in New York, and the answer was, well, yes, tough, that's the way it is. But it was a step in saying we're pulling back from the circumstances in which we'll use nuclear weapons. And that was sort of a big deal. In 1985, Oliphant did this cartoon. And probably all of you can't see this. This is one of these big bombs hanging by a thread over folks sitting in their living room. And it says, actually, after 40 years, I really give it a thought. This was this nuclear Armageddon hanging over everybody's head. And that's why there was so much effort to start building down these stockpiles, because everybody was afraid of an accident. For example, if we were hair trigger, which is where we were for about 30 years, on launch on notice, if we thought the Soviet Union was attacking us, and if it was a mistake, you can't call them back once you push the button. It gets kind of hairy. So the idea was to try to minimize the problem, and this was Oliphant sort of saying, we've forgotten how difficult this problem really is. And if that falls on our heads, you don't have to worry about anything else either. So since we made our recommendations, briefed the Congress, briefed the President and the Secretary of State and the Secretary of Defense, in Prague, the Presidents Medvedev and Obama signed on April 8th this great new START treaty. This START treaty is a huge good deal for the United States. Objectively, it's just a good deal. And what was really kind of fun was on May 3rd in New York at the NPT Non-Proliferation Treaty Review Conference. It was the 8th conference of the Treaty on Non-Proliferation of Nuclear Weapons. Hillary Clinton, for the first time in U.S. history, took our advice and declassified the number of nuclear weapons in the U.S. arsenal. 5,133. It was a huge deal. The Russians were shocked. Shocked. They couldn't believe it. They said, how can you get away with this? And they said, well, if you can do it, maybe we can do it. They haven't done anything yet. But that's a confidence-building measure. We're telling the world how many nuclear weapons we have sitting around that might still be used. It's a big difference from the 31,000 plus we had before. But 5,000 is still a big number, a very big number. These are the two presidents signing that treaty in Prague. That was a big deal. What it does for us is give us a tremendous window into what the Russians are doing. Because we can do on-site inspections. Our folks can walk around with instruments and measure what the Russians say they're doing, they can do the same thing for us. It's pretty intrusive. Without that, we won't have any idea what's going on. They can say anything they want. There's no way to verify it. So this is actually a very good deal for the United States. And it continues what we've been doing with the Russians for about 20 years, actually. The U.S. has been dismantling warheads for a long time, and we started dismantling these warheads in 1994. So a lot of stuff has been sort of taken apart. What you do is, with a nuclear weapon, how many folks know what a nuclear weapon looks like, design-wise, inside? Yes, there's always one. Yeah, it's good. What you have in most nuclear weapons is a bunch of high explosives on the outside. You got a case to make it look nice. Bunch of high explosives on the inside, and inside that high explosives, for uranium weapons, there's a sort of a plunger and a housing. And you shoot a plug into a cup of high enriched uranium, and it just goes off. The other is a plutonium device, where it's much more complicated than just shoving two things together. You have to squeeze it all down. So what they do is they design what they call a pit. It's a hollow shell of plutonium with some stuff on the inside, tritium, primarily as an initiator, and you can just sort of make a thermonuclear explosion out of that. So what you do is you have to take these things apart and dispose of the material. Because you don't want to take the nuclear weapons apart and have all the other stuff laying around so somebody can steal it and use it. Plutonium, for example, is incredibly toxic. It's one of the most toxic metals in the world. And if you want to go and poison a reservoir, for example, it's not an unuseful thing to do. But you also want to make sure that nuclear weapons, when they're taken apart, can't be used again. So a lot of the stuff that's been built down in these times has actually been converted to fuel for nuclear reactors. And once you burn it in a reactor, it's much less likely you can use it for nuclear weapons. We don't have comparable numbers on the Russians. But to give you a sense of how elegant these things have gotten, and this is not, there's some stuff I can't show you. This is the size of the first nuclear weapon that we used. This is the Fat Man nuclear weapon dropped on Russia. I think it was dropped on Japan. I think it was Nagasaki, the Fat Man went down on. 22 kilotons. There's a sort of a person thing. And this is the MK-17. This is a very much larger device, but it's megatons. This is a thermonuclear device. You flew it in a big plane like a B-52 and you dropped it on somebody. This weapon could take out New York. One of them, gone. We intended to take out Moscow or Leningrad, but that was the design. Big thing. And then we advanced in the technology, so we started building nuclear weapons that were smaller. So on the Polaris submarine nuclear weapons, for example, were small relative to the size of a person. They're about the same size as a person. Well, we got fancier, and we did multiple re-entry vehicles that we stuck on Minutemans and Trident submarine missiles, and they're this size. The explosive power of something that size, and that's just a case, is at least the same as this. It's pretty good. I mean, technology at its best, sort of. These are easier to steal than those. And you may also assume that the Soviets and the Chinese, since they stole some of our stuff, spies are good, have things that are about that size. I will comment that we have nuclear weapons as powerful, significantly smaller than that. But there you go. So technology has advanced somewhat, made things a little more easy to use and a little more hairy to contain. The last of those little nuclear weapons, the W-62, which were on the Minuteman III, was dismantled on August 12th. This is the ever-smiling Stephen Chu. Dismantling this, I think it was at one of the storage depots in Albuquerque, New Mexico, at Sandia Labs. And this is just this guy. Anyway, so we take pictures of our dismantling exercises, just so people know. But, you know, that could be a dummy. If I were a Russian, would I trust us? So, pictures don't tell 1,000 words. I want my guys there looking at this thing, making sure that what we dismantle is not a cardboard dummy. That's a part of the verification exercise. Not easy. Not easy. because you don't want to give them any classified information. See if anything happens when I push the button. There. One of the things that we have to do then to make sure that we and the Russians and whoever else is in this game trust each other is we have to be able to decrease the number of nuclear weapons in our stockpile while making sure they actually work. As I mentioned, this is kind of an art. No one really knows that something's going to work unless they test it. Since we haven't tested it for 20 years, these things are getting old. Some of the materials degrade naturally. Some of the struts, not necessarily the plutonium and highly enriched uranium, but other pieces, the tritium dies over time. You have to replace them. But no one wants to develop new nuclear weapons because that's a bad thing. If we develop new nuclear weapons, then there's an excuse for everybody else to develop new nuclear weapons. So we say nuclear weapons are bad. We don't want to develop new ones. We just want to keep what we have in smaller numbers. So we got to refurbish elements of the U.S. nuclear weapons stockpile. The National Nuclear Security Administration, which is a part of the Department of Energy, and its laboratories, we argue, have to adapt for a broader national security mission than stockpile reduction. And the reason why we concluded this is that that is really boring. It's not sexy. If I want to get somebody who graduates with a master's degree in physics or a PhD in physics or in engineering or in chemistry into this game, I'm not going to be able to attract them by doing boring stuff. They all want to get the Nobel Prize or make a lot of money, and they will do neither doing this stuff. So how do you get smart young people to do this stuff? This is hard. It's actually very hard, but you got to be able to convince folks it's useful to do this. And there's some interesting ways of doing this, but this is a very hard thing to do, to get some really bright young people to want to go into this business when you can't blow things up in the ground, you can't do measurements to see how sexy it is. You know, it's just like, why am I doing this? So why we're doing this is that the president has committed to upgrade the nuclear weapons infrastructure in the United States. Even though we're on a continuing resolution, in the budget that was passed last week as a continuing resolution, the president put in another $647 million over what was in the budget before to begin restoration of some of the infrastructure at the weapons laboratories. So there's a building called the Metallurgical Laboratory. Sounds benign, isn't, at Los Alamos National Laboratory. Just to renovate the building is going to cost $4 billion. This was a down payment, $647 million to renovate that, and some other facilities at Sandia National Laboratory. Why? Because you want to make it good and you want to make it sexy so young folks want to go in and play. It's that simple, sort of. One of the things we also need to do is to be able to train folks in nuclear forensics, I mentioned before, nuclear safeguards, nuclear weapons design. But that's, I mean, what do you do with it if you can't test it? What do you do if you don't know it's going to work? So it makes it kind of hard to pull people in. For example, to do nuclear forensics, this thing I said, when somebody walks in and sets off a weapon in, well, I like Chicago, so let me pick another place. I don't know, Fort Lauderdale. I'm sorry, I didn't mean that to anybody like Florida. But how do you know who did it? It turns out you need a lot of radiochemists to go and pick up the pieces and do the analysis. The United States is producing 2 radiochemists a year at the PhD level. A year. And most chemistry departments have gotten out of the business because it's not cutting edge and it's not going to lead to great discoveries and great amounts of grant money coming to the place. It just won't do that. But it's essential for national security. So we have to convince the academy to train folks for the public interest. And then we got to convince folks to actually go into it. So there's got to be something at the end of the tunnel. So we invented, the U.S. government invented, I was a part of this, a program called the Stockpile Stewardship Program. Stockpile stewardship means we're going to go and build down the stockpile, but as we do it, we're going to be good stewards of it and make sure they work and make them safer, make them more reliable. And we're going to do that with really fancy pieces of equipment because it's whiz-bang and then folks will be happy to play. So stockpile stewardship contains a lot of elements. You got to make sure the missiles work. We don't launch nuclear-tipped or potentially nuclear-tipped missiles anymore. We don't test them. And when the Russians think they're going to test them, we get really nasty with them. And we get nasty with the Chinese when they do it. We really get nasty with the North Koreans when they do it. We say there is no excuse for testing this kind of stuff, even though they're probably going to do it next week again. But if we're going to have reliable delivery systems, and most of ours are not going to be on 747s, they're going to be on missiles, you got to make sure they work. That's part of the big stockpile stewardship exercise, and I'm sure that NASA is going to be a part of that because they're the missile expertise along with Thiokol and others who produce these motors. Another is monitoring nuclear weapons from the inside. We need some really smart people to continue to design these fancy little devices, embedded sensors, that you could put inside the nuclear weapons, inside the active part of nuclear weapons, to measure how they're operating, to measure whether they're deteriorating, to do analysis while you're sitting there. You can just see how this looks, and you get a sense of whether you can sort of get rid of these things or not. Well, somebody's got to design these things. It's not going to be like an iPad. That you can come up with all sorts of. This is going to be completely classified. Nobody's going to know you did it. Nobody's going to give you a patent for it. Nobody's going to pay you anymore for doing it. But it's crucial to U.S. national security. It can be sexy inside the house where all the fences are around, but nobody's going to know it outside the house. You won't be able to tell your spouse, but that's okay. If it's sexy enough, maybe we can get over it. I don't know if you can see this, but this is a guy, it really is a guy, sort of doing a reliability test on nuclear weapons at the Lawrence Livermore National Laboratory out in California. So we take pictures of people actually doing this stuff, but you never know exactly what they're doing. A big part of stockpile stewardship is advanced computing. The fastest computers in the world are at the Nuclear Weapons Laboratory. They do some spectacular computational modeling. They do some wonderful things. Any computer scientist will really get their joys, if they can get joys, from this kind of stuff. The name of the program is Hyperion. It's a big deal. We're spending hundreds of millions of dollars a year on advanced computation in this context. So if anybody's a computer scientist and really wants to get into super fast computers, the state-of-the-art, the cutting edge, working with IBM and others, stockpile stewardship is the place, because money is no object. But nobody's going to know you're doing it. That's a problem. My favorite is the National Ignition Facility at the Lawrence Livermore National Laboratory. Now, this is a toy. This is a spectacular toy. It is a bunch of lasers designed to compress a target at the megajoule level with deuterium and tritium so we can see whether our models for your nuclear weapons are actually correct. Because you can't test them, you can't blow them up, so you got to do miniature scale models of these kind of things. And this is a $4 billion device. It just did its first ignition test this week. And they claim it was incredibly successful. Okay, but this is not a little thing. I'll try to give you a sense of the scale. This is the target chamber at the National Ignition Facility, and these are people inside this target chamber. So you get a sense of the scale. You got these lasers shooting into this target chamber, and there's a little target down there, and I'll show you a picture of the target in a moment. There's a target. It's a tiny thing, folks, okay? And you got these rather humongous lasers dumping a megajoule plus on this little red thing here, which is filled with deuterium-tritium gas mixture. That's really hot stuff. Okay, how do you keep from just blowing this thing to pieces? And how do you do a diagnostic? How do you know you've actually done something? How do you measure the neutrons coming out? So it actually is pretty cool. To give you a sense, I don't know how well you can see this, of the size of the crystals that go into these lasers. This is a trolley on the bottom, sort of the size of one of these slabs, and that's a single lasing crystal. It's a big sucker, okay? It used to take 2 years to grow this. They now have figured out how to do it in 2 months per crystal. That's a big engineering feat. We have to do it faster than this because these things are going to burn up very quickly as these things get used. So it's a big deal from an engineering perspective. That should be really exciting. To give you a sense of the size of the lasers these things are used in, these are the lasers at NIF. And these things are people I'll start, there's a bottom and there's a top of a people. These are gigantic lasers. They're absolutely gigantic. To get them coordinated through those crystals from this monster device, there are several large laser bays. Here's a target chamber. There's a control room. We're not there, but that's okay. These are just enormous, but these are really, really sexy tools. And you can do all sorts of things. We argue also, and this is something that's interesting, is that this could be useful for generating energy. This is inertial confinement fusion. If you really get to work and go to ignition and produce enough neutrons, you maybe can produce energy for civilian uses. Don't hold your breath. But it's a good argument for getting money. Because the reason why folks were able to test ignition this week was because they promised that they would get ignition this week. Of course, they didn't. They don't plan to get ignition for a couple of years. But it really worked. The community was all behind it. This is an inexhaustible source of energy. And maybe it will be in 100 years. But to have those gigantic lasers come down and hit something this small, it's just amazing. It's control at its best. And we know how to do this. This is a collaboration with this facility of the British, the French, the University of Rochester, a few guys from MIT, and some others. So it has some significant university components, but it's all classified for the most part. Back in the old days when I was in the State Department, I was in a big fight with the folks at Livermore because I told them, and everybody agreed, that this picture was secret restricted data. To let people know that that's what you could use as a design for a thermonuclear device seemed to be a bad idea. Of course, then a kid from Princeton designed it, with a Mac, but it's okay. This was a problem for us. The reason why you can show it anywhere now, and it's on the web, is that these guys at the laboratories were so desperate to get people into the lab, they wanted to show the really fancy stuff they could do, so it got declassified. It's an interesting exercise. So we have to spend a lot of time and a lot of money, and this is sort of what this is all about, bringing people into this fold of making sure our weapons are secure. Another big deal is to make sure that folks aren't misusing facilities like the Iranians, for example, are, to develop material for nuclear weapons. The big part of nuclear weapons is not the design. As I say, this stuff is 65 years old in design. And besides, the Pakistanis were selling them all over the place. A.Q. Khan was not particularly helpful in this. Sold it to the Iranians, sold it to the North Koreans. Who knows? He sold it to the Burmese. The game is to try to make sure that if somebody has these kind of facilities that can produce this material, they're under international safeguards. You know what they're doing. They're under lock and key. They can't misuse them. That's kind of hard, especially when a lot of folks will find excuses for developing these facilities for peaceful purposes, in quotes, and then they can just break out and do whatever they want. This is a sort of a technical piece. I just put it in for completeness. Elevate the priority of non-proliferation in the Nuclear Regulatory Commission licensing process. We have the Nuclear Regulatory Commission licensed civilian nuclear power activities in the United States, but since they're so good, they are the benchmark for the world. So anywhere you go, no matter what country it is, including in Russia, they want to make sure that their designs can pass the NRC sniff test. Well, that's a good thing, but then we have to pump more energy and intellectual capital into the Nuclear Regulatory Commission process so that they come out with something that really does enforce this regime of nuclear safeguards. And then you got to do some other things with industry. This is this nuclear forensics team I was talking about. Tests have been run. We do all sorts of exercises in the United States that nobody knows about, but cost a lot of money. We sort of, okay, here's an accident. Go in and clean up. Tell us what happened. Here's a fake nuclear explosion. Can you go and tell where it came from? A biological weapon went off. What's the source of the microbes? Chemical weapons, the same thing. This is a big deal. One of the things we have to do is understand what techniques are needed, what expertise is needed, and then work with the academy to train people in those techniques. And so the academicians here got to spend some time working with the nuclear weapons types and other types so we can begin to work together to develop the expertise the nation needs in the national security sense. These are the critical science and technology challenges we concluded. To verify and monitor arms control treaties. As I say, we're the biggest violator of arms control treaties. The United States is. And that's just the way it is. Because, for example, the president and the administration negotiates an arms control treaty. And in principle, once that's signed by the president, the nation, under international law, should act as if it's in effect. Like the Comprehensive Test Ban Treaty. Well, that's been sort of in effect for 20 years. The U.S. has never ratified it. It's never gone through the Senate. That's sort of a bad sign. Everybody else has ratified the thing, except us, and they really adhere to it. Well, you know, since we haven't ratified it, if we broke out and did whatever we wanted, it's not a violation of international law. Well, we have some interesting other things like that. So we need to work with others to verify our own commitment to international treaties and theirs, and dismantlement efforts. We got to sustain this nuclear weapons expertise as long as it's necessary. But it's not just to support the deployed nuclear weapons of 5,000 we have now, but to really also support counterterrorism, a big deal, nuclear forensics and archaeology, and these other things that allow us to know where material is once people have dismantled it. And this is a growing problem. Everybody wants nuclear power. How do you make sure it's not being misused? Good. So that's the end. I appreciate your time. And since you can move forward and ask questions, I'm in good shape.
All right, there's two microphones, one on each side here for people who have questions.
Or you can just shout because, you know, what the heck. Oh, you can use the microphone.
I have a question on the Livermore facility. How effective do you think that would be for really ensuring the reliability of the weapons in terms of, say, long-term perspective, 10, 20 years from now? The study that they do there is fairly fundamental from a plasma physics and fusion point of view, and in fact there's a lot of interest in fusion as well. But how effective do you think it would be on the long term for reliability?
Okay, I won't give you the party line. I'll sort of tell you my real opinion. All that facility is going to allow us to do is benchmark computer codes. So we're going to be able to say, okay, we expect under certain circumstances, when we implode this little device, it's going to produce a certain number of neutrons per megajoule, for example. And that will allow us to say, okay, I predicted this in my computer model, how close was I? And I can fine-tune this computer model. And then I can apply the computer model to nuclear weapons. I can use it to augment any other fiddling I'm doing because the designs are not necessarily as robust. But we rely now almost completely on computer modeling and some explosives but non-nuclear testing to verify the weapons. So the computer codes are becoming much more fundamental. So the National Enrichment Facility is only going to let us verify computer codes and refine computer codes. It's, from my perspective, it's a nice toy. Okay? It's a really nice thing because it's very fancy, and that you can do some really interesting fundamental physics, which is one of the things that can happen. You can get some stuff out there that you can actually publish. And that's why there's been this big push, because once you bring folks into it, they're behind the curtain, they can still do some unclassified work and collaborate with universities, University of Rochester, University in Kyoto, for example, the French, to sort of do some fundamental inertial confinement kind of physics, but it really is not going to do much more than that. But it's very attractive for young people. I mean, that's what it's really about. Yes?
Thank you. I'm just an average, everyday citizen who's a news junkie. And so when I watch a lot of the news programs, you hear the same rhetoric.
Okay, in the case of Iran, who would you want to give guarantees to, for example? In the case of Iran, if somebody wanted to be in a position to deter Iran, who would that somebody be? Would it be Saudi Arabia? Or,
It would be us.
okay,
It would be us as a country. But just like we have bases in other countries, in order to protect our interests, why would we not have bases of nuclear excellence strategically designed and run by the U.S.? And that may be some naivete on my part, but it sounds reasonable to me.
you mean civilian or military nuclear excellence?
Oh, military.
Okay, let me just say that we do have that. There's nuclear weapons deployed in various places, a lot of them on ships now, which is why a more robust Navy is useful. But there are a lot of folks who want to make sure that they have guarantees. And when I was growing up, the best way you guarantee something was to do it yourself. So, for example, when you have a country like Iran declaring that they're going to wipe Israel off the face of the earth, the Israelis think it's really nice that we would say, well, if they came and dropped a nuclear weapon on you, we would retaliate. And the Israelis' answer is, well, you know what? I think I'll take care of that myself. So I don't blame them. You know, how reliable are we? How reliable are we if somebody came and dropped a nuclear weapon on Tel Aviv and killed 1.5 million people? How much guarantee is there that the U.S. would go and take out Tehran and kill 4 million people? Well, you know, So we have that in Europe. We have forward-based nuclear weapons. The question is who we're deterring now. I mean, the biggest problem is not the Russians anymore. The biggest problem is nuclear terrorism. So what happens if you have these weapons deployed and you get a little sloppy and somebody steals one of them? It becomes a problem. So there's a significant effort in Europe to get those weapons out of Europe because they're sort of worried about it. You have a country like Pakistan. We suggested a long time ago that it wasn't a good idea for India and Pakistan to have nuclear weapons. So the Indians tested a nuclear weapon in 1979, and he said, we'll never do it again. Well, a few years ago, the Indians tested a bunch of nuclear weapons at one time, and the Pakistanis responded by testing a bunch of their own nuclear weapons, and we weren't so sure they had them actually when they tested it. Bit of a surprise. The Pakistanis' nuclear weapons are to deter India. The Indian nuclear weapons are to deter China. Well, we're not going to cut that deal, given that China owns 40% of U.S. debt and we want them to really do okay. It's a very complicated thing to do. So we can do that with Japan because there's a historical precedence for that. But the Japanese have not been waiting around. If they didn't think we were going to pull the trigger, nuclear weapons would be there by the end of the month. They've got the material, they've got the expertise, they've got the designs, they can just do it. So those negative security guarantees, which is what they're called, are useful in certain contexts. They were very useful during the Cold War, but if the biggest threat is not a monster like the Soviet Union threatening to invade Europe, they become less obvious in their utility. So they're historical for the most part. But nobody seems to think it's a good idea if, for example, the Egyptians go and invade Israel, which has happened once or twice, with conventional weapons, that we should retaliate on the Egyptians with nuclear weapons. It's just not going to happen. So the Israelis have decided to deter the Egyptians on their own. And that's how it works. One of the things I discovered when I was in the State Department was that the South Africans had nuclear weapons. We were all over South Africa with gloves and sticky tape and everything, and they had actually developed uranium weapons under our very noses and nobody noticed it. And when apartheid fell apart, just before it fell apart, they confessed that they had it and they dismantled it themselves. Nobody had any idea they had them in the first place. This stuff can happen. And so there are a lot of folks who just don't trust that we ought to know enough to be able to help them out when things get tight. That's the problem. It's a very complicated and convoluted answer, but those are the realities on the ground. Yes, sir.
Good evening. I was wondering, is it theoretically possible, or have they been developed, low radiation electromagnetic pulse bombs And if they have, what's going on with that? And is there a race going on behind the scenes?
What do you mean by electromagnetic pulse bombs?
Well, one of the things that would really do in modern society is the electromagnetic pulse that happens
Oh, I got you.
in an
Okay.
atomic weapon,
Yes.
because all of our computer chips would be fried.
Yeah.
And I was just wondering what's going on with the big brains as far as developing a clean, low radiation electromagnetic pulse.
There was a lot of work on those weapons in the 80s, a lot of them. Just you fry the whole power system. It goes out. Or you send a very big pulse down the power lines and you cook all your ICs, integrated circuits. It turns out that there are much more efficient ways of doing it. They're called cyber attacks. If you get some really good people, they can take down your entire electrical grid with just messing with your computer control systems. So it turns out that there are much easier and more efficient ways of doing that. So the whole electromagnetic pulse stuff has gone down the tubes, except for intercepting missiles coming in. So there's some significant work still on missile interceptors. Instead of just flying something up and hitting it or setting off a nuclear weapon in the vicinity so you can wipe out the missile and the warhead before it comes down, some folks are looking at totally disabling the control systems. But that's a little far-fetched. What we're doing now is trying to just knock them out of the sky, just hit them and knock them down. But it was an interesting era when they were doing that stuff, because that was before people got really smart and 15-year-olds could hack into a DOD computer system. And after a while, it became sort of passé. It's also very expensive compared to what they're doing now.
Thank you. Sir, my question is that, I know that Obama is a very peaceful man. That's why he has got the Peace Award. And everybody knows that he's a very peaceful man. But the question is that, the American government's policy towards atomic global disarmament, our CTB, is so biased in one way that it cannot get successful results. Why? One, as you said, that India detonated atomic device in 79. I think, with apologies, he detonated in 1974. And when he detonated that atomic device, the Indian government...
You're right, 74, not 79, you're right.
Yeah, when he did that one, he said that it was peaceful. That atomic device is for peaceful. And the whole world, applauded that word peaceful. And he did it again in 79, 89. And even after that, Pakistan detonated. But the whole world was against Pakistan. And no one was raising any voice against India. So that, one point is good and 1 point for against. As far as Israel, they have got, everybody knows that they have got an atomic device well before, almost 30, 40 years. And nobody is raising any concern about the Israeli bomb. But everybody is saying that no other nation Iran cannot got that one. Is that one-sided got the good results or the bad results? The policy should be uniform.
Oh, life isn't fair. Look, life is... If you think it's going to be fair, you're in the wrong business. When the Indians, and you're right, they set up their first bomb in 1974, people got really angry. Okay? And India got beat up pretty badly because one of the problems with this whole nuclear weapons business is that a lot of our folks were saying that there were peaceful uses for nuclear explosions. They were going to go and liquefy natural gas and do all sorts of crazy things, crack oil shale, all sorts of other nutty things, just so they could test. Because the nuclear weapons design were sufficiently fragile that nobody could be sure they would work unless they tested them in the ground. Okay? So there was this whole rubric, and there were books written on peaceful nuclear explosions. There are no peaceful nuclear explosions. It's completely nonsense, okay? You blow it up, there's nothing peaceful about it. And we know that, because even if you go and crack the oil shale, you can't do much with the oil that's coming out because it'll be radioactive. I mean, it's just nonsense. But people beat up on India, and that's the reason why India backed off really fast. They didn't do another one for a long time. And when they did it, the weapons, those things were weaponized. The Pakistanis have been working on it quietly for a long time. They had gotten some designs from the Chinese, their Chinese friends, which is really annoying. So the Chinese were proliferating before the Pakistanis proliferated. And they had designs that worked, but they were literally just to be a counterpoint to the Indians. But the difference between India and Pakistan is that Pakistan's fallen apart, okay? Politically and otherwise. And if somebody gets their hands on a Pakistani nuclear weapon, you have a problem. It is highly less likely that India is going to fall apart in the same way, okay? It just, when people look at the Pakistani situation, it scares folks because what happens when the Pakistani army or their intelligence services who have been supporting the Taliban aggressively for the past decade just passes one over? How do you deal with that? And we're not sure the Pakistanis would know if it happened. That's the problem, okay? The Indians we have a much better handle on. We don't like them either. But you have to remember, back in the old days, the Pakistanis were our friends and the Indians were our enemies, and now the tables have turned, so we love everybody. But the political reaction has got to be seen in the context of the time in which the reaction took place. But none of these guys are particularly good actors. And none of them, what are they going to do with them? So you have India with a couple of dozen nuclear weapons in this gigantic landmass with 1.1 billion people. And you have China with probably 1,000 nuclear weapons, almost all of them thermonuclear, in a country which is gigantic landmass with 1.3 billion people. Okay, who's going to fry who? I mean, it sort of doesn't make any sense anymore. So the point of making them is kind of crazy. The only reason we think the Iranians want nuclear weapons is because they're Iranians. Okay? The Persian Empire has been around for a long time. They feel as if the Israelis have nuclear weapons. Why should anybody pick on us? And they're aggressively trying to do it. But they're declaring they want to wipe the place out. They've also been destabilizing the Saudi Arabian government, which has its pluses and minuses. They've been certainly killing our troops in Iraq and Afghanistan. And people just don't think it's a good idea for these folks who have declared their antipathy towards Israel and to the United States, and lately the French, they didn't like Mrs. Sarkozy, they called her a few things. They're playing games that just make people unhappy. And that being the case, you know, you get on everybody's negative list. North Korea is the same thing. But that's over. What are they going to defend themselves against? Well, there's Kashmir, I remind you, which is completely falling apart. The problem is that if the Pakistanis are not careful, there will not be a Pakistan in 5 years. There may not be a Pakistan in 2 years. What's going to happen to the weapons? Politically, the place is falling apart. That's a problem for everybody. Because then the Chechens get nuclear weapons. And instead of setting off these Black Widow bombs in the Moscow subway, they set off a half a megaton device. I mean, that is not unlikely. That's the problem, okay? It's not just us. Well, I don't know. I was in Pakistan a couple of months ago. Pakistan doesn't look like a place that I want to spend a lot of time. No, look, if you take a look at politically, that is not correct. You have sufficiently many terrorist attacks in Islamabad, in Karachi, and elsewhere that it's not clear. If you take a look at the border with Afghanistan, you know, nobody controls it. That's it. Okay, yeah. We can discuss this over schnapps or something.
When it comes to nuclear terrorism, for example, you indicated that the real concern is not state to state, but the probability or the possibility of a nuclear terrorist act. Any event that does not have exactly zero probability will, given enough time, will happen.
Yep.
So how safe are we? What do you suppose would be a good number for the meantime before we actually have a successful terrorist event?
9/11 wasn't predicted either, okay? The biggest fear of the U.S. military and the foreign policy community is nuclear terrorism. I mean, it's the biggest fear. And that's why folks are so worried about loose nukes, especially in Pakistan and in Russia in some areas, where we're spending a lot of money helping them secure their nuclear weapons. Because some people feel that it is a certainty that it's going to happen. Okay? The question is how you know who did it and how you get them back. How do you deter it? The only way we know how to deter it now is to do a lot of spying, secure the material. We're spending a lot of money securing the material, and killing the terrorists before they kill us. I mean, that's really what we're doing. It's worked so far. There haven't been major terrorist attacks. I mean, we had a slip up in New York. That could have been a mess. But you can't, it's hard. When folks are determined to get you and they don't mind committing suicide, it's almost impossible to stop. Yeah. The only way you can stop them is to keep them from getting the stuff in the first place. And that's what all the effort is. The effort is trying to not let them get the stuff in the first place. If they get the stuff, they're going to use it. There's not even a question about it. Not even a question about it.
Just a quick follow-up. Have there been any cases where there clearly was a plan in place for a nuclear event and it was thwarted, either in this country or abroad?
I can't say for sure, but likely. I can't say for sure, because I'm not allowed to say for sure, but it's not unlikely that there were efforts. The question is whether they were credible efforts. Now, we know that folks have been buying uranium and other nuclear materials on the black market, and we know there are folks who are planning to send them off. We caught a couple of these folks. We caught a couple of folks who are doing the smuggling, and they had plans to use the material. Nobody had an assembled weapon. And if you put one of the things that drives me crazy, and I was doing this, and it still drives me crazy, is that you have folks who you don't want to have nuclear weapons who have them. And I won't name any names. You know they have them, and you want to make sure that nothing bad happens with them, so you help them make the nuclear weapons safer. You go in and help them build safing devices on nuclear weapons so that somebody stole them, they couldn't set it off. That kind of stuff, I mean, it's counterintuitive, but if they have them already, you don't want them to screw up, so you help them make it safer. So we in some sense, we're aiding the stockpile building of certain countries. I won't mention who, but it's one of those things you just want to make it so hard. If you can't keep people from getting them, you want to make them useless when they get them. And the game is to just work like hell to keep that from happening. But you're right, the probability is far from zero. It's the biggest concern of the military right now. Bigger than Afghanistan or Iraq. They're convinced it's going to happen. It's hard.
Very good. Thank you.
Hello.
Hi.
I speak kind of loud, so I'm trying to gauge this. Okay. My question is, in general, why are we not a more informed nation on the countries that have the capacity to create and will use nuclear weapons? For example, the New START treaty that was signed on April 8th, why are we not as informed on this as we are on domestic issues?
Because there's so much noise out there. I mean, the treaty itself is pretty straightforward. You can get it on the State Department website. I mean, folks have got to go and look. What you've got to do if you want to be informed publicly is have a discussion that's not in sound bites. So forget television, forget talk show radio. Most of the newspapers won't publish this stuff.